is performed strictly in accordance with the American Welding Society specification D1.1. Measurement of preheat temperature and the selection of welding current, gas flow, welding voltage, and welding consumables are strictly controlled. Preheat temperature is measured using infrared thermometer. A carbon dioxide gas arc welding procedure is employed. Large, numerically controlled cutting equipment is used to cut materials for structural members. The use of NC equipment enhances the reliability, repeatability, and dimensional control of this operation. Welding grooves are beveled by machining or cutting and grinding. Shallow grooves of 100 millimeters or less have a roughness of 25 micrometers or less. Deep grooves of 200 millimeters have a roughness of 50 micrometers or less. Mud pump frames are welded with special welding equipment. All major welds employ multi-layer and multi-pass welding procedures. The post-weld frame therefore boasts high welding strength and a sound weld appearance. Mud pump frames are finished with the most advanced numerically controlled boring and milling machining center. This significantly improves the precision, finish, form, and position tolerances of the machined frame. The herringbone gear shaft and gear ring for our 1600 horsepower high-pressure mud pump are designed to be of the integral type. Imported Sykes machines are used for rolling, milling, and planing the gear to satisfy the exacting requirements of machining the left and right hand tooth form. The precision of engagement that results ensures a lower friction, longer lasting set of gears. A forged crankshaft is now employed in our 1600 horsepower high-pressure mud pumps. This provides high strength, rigidity, and smoother transmission and longer service life than can be had from castings. Modules are machined with a numerically controlled machining center to ensure that the form, the position tolerances, and dimensional tolerance are well controlled. Local surfaces inside the modules are shot blasted to strengthen the anti-fatigue, anti-stress, and anti-corrosion cracking and anti-seizing characteristics. The Yellow River rig is painted in two newly built, advanced, indoor coating, spraying, and baking production lines. The parameters, such as temperature, airflow, etc., can be adjusted and controlled to obtain high-quality coatings which will ensure long-lasting protection. The Yellow River rig employs world-class quality paint. With high corrosion resistance properties, all coatings are applied in compliance with painting standards for offshore rigs. All painted parts are free of defects, which yields a smooth and glossy finish with strong adhesion, high corrosion resistance, and 12 to 15 years of corrosion resistance protection. LSNOI employs modern quality management systems and sound inspection methods. The whole process, from material purchasing, blank manufacturing, to parts machining, is strictly controlled to ensure that only high-quality parts are used on the rig. A quality tracing team has been set up to comprehensively trace, supervise, and control the overall quality throughout the entire process. The tracing management for raw material and blank is based on the "whoever removes shall mark" principle, which ensures that picking list, order sheet, transfer sheet, and warehouse warrants always match the tracing marks of the physical product and match those recorded in the quality documents. Critical parts are traced and recorded in accordance with specification QS 3001. The material, size, and material tracing marks of parts to be cut are inspected and checked to make sure that the entire product is traceable. Hoisting components, such as crown blocks, traveling blocks, hooks, and swivels, are manufactured to API 8C. As such, they are subjected to visual inspection, chemical composition test, and mechanical property tests in accordance with API 8C. In addition, the material qualification test of castings for primary load-carrying parts is performed by large-size specimen sampling. The NDE is performed on the primary load-carrying parts as per API 8C, ASTM E709, and ASTM A388. Additionally, machined surfaces on primary load-carrying parts are examined by wet fluorescence to ensure that only high-quality components are used in making our hoisting equipment. The design verification test of hoisting components is also performed in compliance with API 8C. The hydraulic test is carried out to 2 times the working pressure. The tension test is performed to 2 times the design load. After the tension test, the product is disassembled and re-examined with results recorded for future use. API 8C fabricated sheaths are submerged automatic arc welded. The quenched groove of the first sheave is hard tested. Destructive examination is performed to check the depth of case, with the results recorded and maintained. Welds are inspected in accordance with API 4F, API 8C, and AWS D1.1. The welding procedure and the welder's qualifications are evaluated and verified. On a marble platform with high precision and stability, imported digital height gauges with precision up to 1/100th of a millimeter are used to inspect the form and position tolerance of critical parts such as crosshead, intermediate rod, and piston rod. Testing data is precise and direct. To inspect our mud pump frames,